I know simplifying square roots yesterday was new for you. Today is most definitely gonna be new as well. Morning. Right there. Were you gone yesterday?
I was gone Monday.
Okay, that'll do it.
Was you in the
Right there.
calamari?
No, I wasn't.
No.
I was gonna recommend you use that one, yeah. I don't have a screwdriver here, otherwise I would take that off the wall.
Why you ain't got a screwdriver?
Because I don't have my garage right next to me. Danielle, where's Danielle?
He's right there.
Okay. Are you gonna go today, or are you gonna pick somebody else? Okay. Yep. 1, 2, 3, 4. Ellie. So we're gonna start by simplifying both of those. That's what we did yesterday.
Okay.
So there's the two different methods you can use. I left all the square roots up on the board so that, you know, if you need that info, it's up there. Okay, so we're gonna start with square root of 125. Do you need a refresher? Okay, so one of the methods, you're gonna make a factor tree for 125 and look for pairs of numbers. The other method is to look at these numbers that are on the whiteboard right here, the perfect squares, and figure out which one of these goes into 125. It's not 25 and 100, it's 25 and 5
Oh.
times. Yep. Okay, yeah, no, that's perfect. So square root of 125 is gonna be square root of 25 times square root of 5. Okay, Ellie? Another person. Okay, Nene, put your feet down. Take sunglasses off. Yep, take sunglasses off. What? Oh, take sunglasses off too. Was it the teacher from next door? Oh. Okay, Dee you volunteered. Let's go. How do we simplify square root of 216?
Okay, give me a hint.
I can. I'm wondering why you volunteered then. So you can either take 216 and break it down into factor tree, or you can figure out if any of these numbers go into 216, which,
Which one was that one? Was that the factor or was that putting it in?
which way did Ellie do?
Yeah.
She figured out what numbers go into 125.
Yeah, I can do the same thing.
You certainly can.
Let's go 3.
3 is not one of these numbers.
Let's go 16.
Okay, so on the calculator, you would do 216 divided by 16.
Can I do that?
Yeah, do you have a calculator? Use your phone calculator.
I got a phone.
You got it right there, yep. Now, I don't know if that divides evenly or not. I don't think it does. Doesn't?
It's 13.5.
Yeah, so no, that one doesn't work. So 16 doesn't go into 216. My next guess is to try 36. 216 divided by 36, I feel like it's gonna be 6. Okay,
It's 6.
perfect. So then we're gonna say square root of 36 times square root of 6. Okay, nice. You wanna give me a person or a number to go next?
Let's do 500.
That is a number, you're right, I did not specify. I was hoping for a number under 10.
My feet.
That's not a number under 10.
My feet.
Is that how you pronounce your name? Oh, that's what I thought. She just likes to make up names. Okay. Where do I go from here? Okay, what's the square root of 25? Yeah, you can look up there if you need to. So then we would write this as 5 root 5.
Um,
6 root 6. Okay, now I'm gonna write it next to it because I'm out of room here. Okay, Moa, who's going next? 5. 1, 2, 3, 4, 5. Wes. Let me write a different example up top. Wes, how come we can add these together? Okay, they both have the same thing. So you're saying 3 of the x's plus 2 of the x's. Well, if I erase this and I say 5x plus 2y, what do we get when we add those together? You can't add them together because they have different terms. Okay? When you're dealing with square roots, they work the same way as variables. These two have different square roots, so we can't add them together. If I'll erase this and make up a problem, shouldn't write it down. If for some reason they both have the same square root, then I could add these together and I could say the answer was 11 root 3. But they don't. They don't have the same square root on them. Oh, should I go over how come I got 11?
It's 5 plus 6 equals.
Yeah, the number in the front. Go ahead.
Oh,
So, when you're adding and subtracting things, they have to have the exact same, thing with them that you're adding. So since these both have a different square root, this actually is just gonna be our final answer. If, for whatever reason, they have the same square root, then you can combine them together. So adding and subtracting work that way, just like adding and subtracting before. Okay, wait, where did I go? Oh, Wes, you went. Who's going? Yes. 6, 1, 2, 3, 4, 5, 6. Brody, should we start the next one, or, sure, why not? Square root of 512 minus square root of 100. Oh, I don't like this problem, actually. I don't think, is 512 a perfect square root? I don't think so. I think it's 256. I didn't even go that high up there. Square root of 256 is 16. Let's change this problem, let's make it different. Because I want one we can add or subtract together. So let's make this square root of 200. That'll be a nice easy change that you guys don't have to change much, and then the problem will work. So square root of 200. So square root of 512 minus square root of 200. Okay. Now, I don't know if you heard me say out loud 512 is 256 times 2. Okay, so I'm going to write this as square root of 256 times square root of 2. And then how about square root of 200? What would I do with that? Does one of those perfect numbers go into 200? Yes,
Oh, wait, yeah, well,
the one I changed it from.
oh, yeah, 100,
Yeah. So square root of 200, we would write it as square root of 100 times square root of 2. Dee, I gotta send you out if you can't do anything or follow along with us today.
I'm doing it
You're not.
in my brain.
You're not. Okay, Brody, pick a number.
4.
4. 1, 2, 3, 4. Chloe. Okay, I've kinda got it set up for you. Square root of 256, I don't have it written up there, but it's a perfect square number of 16. So I would write this as 16 square root of 2. What do I do with the next one? Perfect, that's all. Okay? And then I'll let you pick on somebody to finish the problem. Yes. Oh, that's a big number. 1, 2, 3, 4, 5, 6, 7, Caleb. What would I finish this with? I've got 16 square root of 2 minus 10
Caleb.
square root of 2.
Oh,
Two minus 1960.
Perfect. Wait, what did you say, 9?
slick back.
Two minus the 10 minus 60.
Oh, yes, I just heard you bad. So then, what's 16 minus 10? 6. So the answer is 6 root 2. If they have the same square root, you can put them together. If they don't, then you leave them apart, like the first example. Okay, now, that's for adding and subtracting. Caleb, I need a number. Or a person.
What about 10?
Sure. 10. Abby,
Abby.
stop asking that.
I'm trying to get to know people.
Yeah, well then wait for the person that talks.
You Abby?
Abby. So we just did adding and subtracting. Now, if we're doing multiplying, is there anything we can't multiply together? I'm not sure how to phrase that differently. No matter what I write, can I multiply things together? Do you remember when we did variables? Like 2x times 2x?
You supposed to put a parentheses?
Okay, could we multiply those together? We can, yes. So when we multiply those, we would like add their powers. Multiplying and dividing, you can put anything together. So we're gonna do square root of 80 times square root of 45. We need to start, I guess, I started by talking about that because adding and subtracting is generally actually the hardest thing because you can only combine them if they're the same square root. Multiplying, it doesn't matter what you have. So let's start by simplifying each one of these. And I'll have you just do one of them. How's that sound? Square root of 80? Okay, how do I simplify square root of 80? You can, or you could do the factor tree. It doesn't matter which method. I don't know which way you did yesterday. Sure, we can do that. Yep, okay, so 80, I'm gonna do as 20 and 4. Is this too much pressure? Okay, do you want somebody else to finish it?
I'll
Okay.
finish it.
No. Oh, okay, Sana. I bet she's feeling really happy that she got to sit by you. Sana, how do I finish this? Okay, I can do 4 and 5, absolutely. I'm gonna circle the 5 because that is a prime number. 2 and 2, and I'm actually gonna do it on the other one as well. So 2 and 2, 2 and 2. Is this how you did the problems yesterday too? Okay. Do you remember what we looked for? We looked for pairs of numbers. So as I'm doing these problems, if I'm doing the factor tree method, I'm looking for pairs of the same number. So I've got a pair of 2's and a pair of 2's and a 5 that's not a pair. So the way these work, if you have a pair, that number would be written on the outside of the square root. So I've got 2 different pairs of 2's, and any number that's not a pair is written on the inside. So this one turns into 4 square root 5. So either method absolutely works. For the most part, people usually understand one more than the Okay? Is there somebody you want to go next, or a number? 6. Chloe already went. 6. Coda. How about square root of 45? Okay, so you did square root of 9 times square root of 5. Perfect. So then this turns into a 3. Okay, good. Now, when we're multiplying, we're going to multiply the numbers on the outside of the square root separately than the numbers on the inside of the square root. So I'm going to take this one and say 4 times 3, give it a 12. And then I'm going to multiply the numbers in the square root together. So I would have square root of 5 times square root of 5, which is square root of 25. And then sometimes when you put the square roots together, you have to simplify it again, which 100% is annoying, but that's kind of how it works. Is that what you were gonna ask? Okay, so what do I do with the square root of 25? It's at 5, correct. So square root of 25 is 5. And then this would become 60. Oh, sorry. I even remembered to shut the shades this morning so you guys can see the board. So all the multiplying problems will work the same, where you're, bless you, you're basically just trying to multiply everything together, but you try to keep the numbers outside and inside separate. 4, Alan. So my next kind of problem is division. What I need to do is I need to do the top and the bottom separate. Now, I don't remember which way you like doing. Do you like doing this way, or do you like doing the factor tree? Okay. I'll help you with 147, because that one's kind of a harder one. And I don't know if you can spot it or not. That's fine. Okay, so 147 has 49 going into it. Okay? So how would I do that? How do you, I know the answers, but what would you do on a calculator to figure out? I would write this as square root of 49 times what? What number would I put in the other one, or how would I figure out that other number? On a calculator, you would do 147 divided by 49, and you'd get 3. I knew the answer.
I can't see Mr. McCloy.
Okay. I'm trying to think of a good way to answer that. So since I knew it was close to 150, I sort of looked for numbers that would go into it, and I knew 9 went into 27, so like a 7. I don't know, a lot of years of practice. Otherwise, you guys can guess and check, like just try numbers. Okay, square root of 200 on the bottom. I bet you could lead me on that one. That one's a little bit easier knowing what goes into it. Okay, which one of these numbers goes into 200? 25 actually does. That's not wrong. This one's gonna be the biggest one. But 25 would have worked.
Wait, who are you asking?
Alan? Excuse me?
I said, oh.
I know. We don't say anything negative here about that.
It wasn't even negative.
It sort of didn't sound positive.
Decide.
Okay, Alan, pick a number for me. Good, that was not hard. It was not hard. Taylor, you're 5. Any thoughts as to what I should do now? So what I haven't done yet is I haven't made these answers. So like, I know what the square root of 49 is, I know what the square root of 100 is.
49 would be 7.
Okay? So,
And then 100 would be 10.
perfect. Maybe. Okay,
No,
now,
100 would be 2 if you really think about it.
no.
Okay.
Now the division ones, there's actually not much we can do with it. The only thing we look for is we check if anything can reduce or cancel. Let's call somebody from over here. David. David, if these were both a square root of 5, what could I do with them? Like if I, let me write a problem next to it that's not the same. Let's say you end up with this.
Or you can cancel the.
You can cancel the 5s. What the heck? And then what else? I heard you kind of saying it.
Simplify.
Then you could simplify the 2 and the 8 by reducing the fraction like a normal fraction. So you would divide top and bottom by 2 and you'd get 1/4. So when you're doing division, that's honestly the only thing you look for in the final answer. Otherwise, if there's nothing you can reduce, you just leave that. So division ends up being the easiest, even though most people probably are gonna assume it's the hardest. We just can't do anything with them. Okay, here's what I would like you guys to try. I have to zoom back out. I would like you guys to try these 4 problems. And then we'll put the answers up in like 15 minutes or something. Now, I understand that if you didn't have a lot of practice yesterday or whatever, today's probably seems kind of strange, or I should say difficult. That's not a calculator.